Okay, so today is going to be the second day of lesson 6.3. We will finish lesson 6.3 today. We're going to talk specifically about Cramer's rule. Cramer's rule was named after Cramer, believe it or not. Okay, it was named after Gabriel Cramer, who didn't live very long. You can see 1704 to 1752. A little bit about how smart he was. At age 18, he was awarded a doctorate. So some of you are 18. Yeah. Okay. At age 20, they made him the co-chair of math at that university in Geneva, Switzerland. And then at age 30, they made him the chair of the math department. So obviously, you can see he's a pretty smart guy. He came up with Cramer's rule. Now, Cramer's rule is another way to solve a system of equations. So far we've got reduced row echelon form. That was using an augmented matrix. We've got using an inverse matrix, which is what we covered yesterday and today. Now we've got Cramer's rule. Now Cramer's rule uses determinants to solve a system of equations. And so we haven't used determinants yet. And determinants, we're going to talk a little bit about how this works. But what we're going to do to find the x-coordinate is we're going to take dx divided by d. To find the y-coordinate, we're going to take dy divided by d. And to find the z-coordinate, we're going to take dz and divide it by d. Okay, now we can do this for a system of two equations, and that's what we're going to look at first. And then we're going to look at a system of three equations, and then you'll have the rest of the time to work. And so when we find the determinants today, we're going to actually use our calculator to find those instead of finding them in a long way. So first of all, let's go ahead and look at this system of equations. 4x minus 2y equals 10, and 3x minus 5y equals 11. Now I understand elimination substitution probably a little quicker here, but what we're going to do is look at Cramer's rule on a scaled down version first, and then we'll look at the system of three equations next.
Can you check it with elimination substitution?
So now what we're going to do to solve this by using Cramer's rules, we've got to find three determinants. We've got two equations, we're going to have three determinants. If we had three equations, we would have four determinants. And so first of all, I'm going to start with d. Now what I'm going to do to find d, okay? Remember a determinant only works with what type of matrix? Square. Okay, so basically since I've got two equations, I'm looking at 2 by 2s. So to find d, I'm going to take everything to the left of the equal sign. So my determinant here will be 4, negative 2, what? 3, negative 5. Okay, that's d. Now dx, on the other hand, I've got to think about something. What haven't I used?
10 and 11.
The 10 and 11. So what I'm going to do is, since I'm finding dx, I'm going to go to the x column. And in place of 4 and 3, I'm going to put 10 and 11. And then I'm going to leave the y alone. Okay, so with that in mind, dy. What do you think you're going to do with the x column? Do you need something?
Leave it alone.
I'm going to leave it alone?
Yeah.
Game starts at noon tomorrow. No JV.
Makes me happy.
Okay, so now, what do you think you're going to put in the y column?
Negative 2, negative 10.
What do you think?
10 and 11.
10 and 11, there you go. So this is the thing, whatever you're finding the determinant of, if you're finding dx, dy, you're going to replace that column with what's on the right of the equal sign. And so now all I need to do is find those determinants. I will tell you in a 2 by 2, it's probably quicker to do this by hand than using your calculator. So in a 2 by 2 here, I'm going to multiply 4 by negative 5, and I get?
Negative 20.
Negative 20. I'm going to subtract the other one, which is?
Negative 6.
Negative
Just add
6.
positive.
So you add positive 6 and you get your determinant to be negative 14.
So that's what the answer is.
That's what d is. Now we're going to do dx. We're going to do the same thing here. Here I get negative 50
Plus 22.
minus negative 22, which is negative 28. On this diagonal I get 44 minus 30, which is 14. Now, in order to find your solution, this is what you're gonna do. You're gonna take dx, which is negative 28, you're gonna divide that by d. To find y, you're gonna take dy and divide it by d. So do you see how that worked? Dx divided by d, dy divided by d. What is your solution then going to be?
Okay, I'm kind of confused about that last step.
Yeah, I am too.
Dx divided by d.
Okay.
To find the y, dy
Oh,
divided by d.
alright.
So what's your solution gonna be then?
2.
2, negative 1. We don't have a z, so we're not gonna worry about a z in this problem. We will add a z when we add a third equation. So that is your solution. And as I said, it's probably a little faster to use elimination or substitution here, but what I wanted to do is look at a smaller problem first before we tackle the big one.
That's still faster than yesterday.
Okay, so let's go ahead and look at this one. 4x minus y plus z equals negative 5. 2x plus 2y plus 3z equals 10. And 5x minus 2y plus 6z equals 1. So now here, since I have 3 equations, I'm going to have how many determinants?
4, 5,
4.
4.
Because when you had 2 equations,
Oh, yeah, 'cause of
you had
D,
3 determinants.
X, Y,
When you
Z.
have 3 equations, you're going to have 4 determinants. So first of all, we're going to start with D. D is
4,
4,
negative 1,
negative 1, 1,
2,
2, 2, 3, 5, negative 2, 6. Now instead of now entering this in on my calculator, I'm going to go ahead and write out dx, dy, and dz, and then I'll calculate all 3 of them at the same time. So dx, I'm going to go to the x column,
Replace it with negative.
and I'm going to replace it with negative 5, 10, 1. Y stays the same, z stays the same. What about dy?
4,
X stays the same. What does y become?
Negative 5,
10, 1.
And z stays the same. And then last but not least, we're going to have dz. I know that on dz, x stays the same. Y stays the same. Z becomes negative 5, 10, 1. So now what we're going to do is enter these in on our calculator. So go ahead and enter in matrix A. Enter in the first one for D. Hey, enter it in. Let's go.
Sorry.
It's gonna take a really long time.
What do you enter?
So enter in matrix D.
How do you actually
Once you enter it in, you need to quit. And then how do we find the determinant?
Go to math and
Where's
then
quit?
delete.
Yep, quit is located right next to the blue.
Second
So
thing.
go to the math, or go to the math menu, and so you should do the determinant of matrix A,
55.
and that comes out to be 55.
Wait, how did you get the?
Okay, did you quit?
Yes.
Second matrix. Yes, go to matrix and then go to the map. Okay, now, what I would do if I were you, I would just change matrix A for dx, and then you've already got determinant of A in your memory, so you can recall that.
Wait, do what?
Okay,
Okay, yeah, it's fine.
enter in,
dx is negative 55.
enter in dx, or enter in dx in matrix A.
Okay.
Did you do that?
No.
Okay. The reason why is once you do that, you can recall the determinant, this whole thing right here, you can recall that, and then you don't have to type it in again. Did you get that all entered in?
I just replaced negative 5, 10, and 1 for 4, 2, 5.
Okay. So then now go back to your main screen, and then recall it. go the second and then your entry. And see, then it calls it back up again, and then you can hit enter. So what'd you get? Negative 55? All right, let's do the same thing for dy. Does somebody already have dy?
165.
You got what?
165.
Okay.
165. I also got 165, so he's correct.
165.
Didn't say it.
And then, last but not least, we need to find dz. 110. And that is 110. So now to find my solution, this is all you do. Negative 55 divided by 55. What's to find y?
165.
165 divided by 55. And 110 divided by 55. For those of you that are wondering where that came from, dx over d, dy over d, dz over d. So your solution is actually
Negative 1. 165.
3, 2. Negative 1, 3, 2. So that is a way to solve this system of three equations. Cramer's rule actually works fairly quick, especially if you have a graphing calculator.
All three are just.
On your test, this is what you're going to have to do. You're going to have to find this, 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 and this. It's actually going to be 5 checks.
Nice. I like more points.
Not
Not
the
points.
All right, so for tomorrow, or for Monday, you need to go ahead and add that 5 through 8 that you should have had from before. So 5 through 8, after I showed you how you can do the inverse on the calculator. And then you need to go ahead and do 11 through 18. And that should be it for section 6-3.